Well, how are you everybody who is watching this video? I would like to take this opportunity to welcome you into our interesting moment of learning about the beauty of calculus and engineering mathematics. Welcome. For the physical students, you're warmly welcome into lecture 3, into the topic that called the Laplace transform for our undergraduate studies or bachelor degree in different fields of engineering. If it's the first time to meet me, my name is Olenjolai. I am a Tanzanian. I thank God who have given me a gift of teaching and a gift of engineering. So I am a teacher, but also I am an engineer. So I will be combining those two skills to make sure that I will be teaching you about engineering and scientific mathematics. Actually, it's applications of mathematics in different fields of engineering. So I have some physical students, but I have also a number of students who are not physically in this class. So one thing which I want to tell you that this is our serious lectures. Make sure that you write, because mathematics is actual mastered by doing. We are going to have learn, try, and practice. That's the technique that we are going to use. We are going to learn the particular concept. I will give you some questions to try, and I will give you some questions to practice, because mathematics is all about practicing before the exam. And I want to tell you that in advance, I will try my level best to use a very simple language, even for the adult students, teenager students. They will understand what am I going to teach them. Another thing that what you should expect in this lecture, I will be solving some questions which have been asked in different exams, such as test 1, test 2, some of the questions are asked in the final exam or university exam, end of semester exam, and even supplementary exam. So I will be giving you the full package. Listen, take care, understand, master. After that, I believe that you'll be enjoying the modules of mathematics in the field of engineering. So concentrate, ask questions, and practice what am I going to tell you. Pronounce what am I going to ask you to just to pronounce. Enjoy, because mathematics is beautiful, and every student who is pursuing any degree in engineering is competent in mathematics, because you have been good in mathematics since kindergarten. That's why you are pursuing engineering field. The only challenge is sometimes some teachers they forget that you have forgotten some skills or some concept. So in this class, I'll be trying to be simpler in such a way that you enjoy and can carry the content. How are you, engineering students? Let me appreciate about physical students. How are you, engineering students? Are you real fine? Yes. Well, are you ready for lecture 3? Yes. Yeah. So it's a department. This is Tanzania Online Institute of Technology. It's our online school. We have some departments. One of the departments is called the Higher Engineering and Scientific Mathematics. We engineers and scientists, we apply mathematics to solve real life problems, right? And then the module name is called the calculus. I'm using the curriculums of DIT, and some of the courses they study engineering mathematics. Their contents are closely similar, right? And then this is chapter 2 called Laplace transform. Say Laplace transform. Laplace. Say Laplace transform. Laplace. Well, and then we are in lecture 3. That's called the Laplace transform of trigonometric function. Say it. Say the name of the lecture. Say Laplace transform of trigonometric function. Laplace transform of trigonometric. Ali Kisalinge, you are not pronouncing. Say Laplace transform of trigonometric function. Yeah, so in this lecture we are going to talk about only trigonometric function. We are not going to talk about hyperbolic function. We are not going to talk about the exponential function. We are going to focus on what is trigonometric function. However, that sometimes we are going to touch about complex number a little bit. We're going to touch about exponential function a little bit. But the theme is trigonometric function. Are we together? Yes. Yeah. We are going to have one integration or one in the derivation, we're going to have integration, so you should not worry. It's a simple integration, right? So let us do the quick review. Quick review, it means that we remind ourselves about what we learned in previous concept. So quick review of lecture 1 and 2. Okay? And this quick review is very important for you to understand lecture 3. The first point that you have to remember for the rest of your life, it's the mathematical definition of Laplace transform. Laplace transform. So the mathematical definition of Laplace transform is this one. Laplace transforms of FFT, remember this formula, is equal to FFS, capital letter, capital F, or let's say that is equal to what? Integral from 0 to infinity of e power negative st, then FFT dt. This is very important and powerful mathematical formula of Laplace transform. Are we together? Or we can write this formula in this form. We can write this formula in this form, that FFS is equal to integral from 0 to infinity e power negative st, then FFT dt. So do you see that we changed here? And then the difference, this is lowercase f, this is capital F. So whether this formula or this formula, both of them are Laplace transform. But this is in case if the variable is t, the dependent variable is t, right? What if the independent variable is x? Well, this Laplace transform is simple. FFS is equal to integral from 0 to infinity e power negative sx, right? Substitute t by x, right? Then ffx dx. Are we together? dx. So, if this is the case, then this is another form. Are we together? Then another formula is, you have to remember Laplace transform of the constant function. For instance, you've been asked to find Laplace transform of 40 of 2. 2 is constant number. Or Laplace transforms of 4. 4 is a constant number. So the Laplace transform of 4 is equal to 4 over s. That's all. So that's why we say that it's it's a over s. Right? What does it mean? Laplace of 6. This is equal to 6 over s. That's all. That's the meaning. Okay? These are some standard function. Also, I taught you in lecture 1 how to derive Laplace transforms of e power a t. This is equal to 1 over s minus a. Are we together? In lecture 1, I did derivation. Okay? And then, in lecture 1, I taught you how you can derive Laplace transforms of e power negative a t. Right? This is equal to 1 over what? S plus a. In lecture 2, I taught you Laplace transforms of hyperbolic function. Say hyperbolic function. How many hyperbolic functions do we have? Total, how many hyperbolic functions do you have? 60. Very good. The first one, conch. The second one, sinh. The third one, tanh. The fourth one, sech. The fifth one, cosech. Another one, the last one, cos of x. But in Laplace transform, how many hyperbolic functions do we study? Only 2. Laplace transforms of 40, conch of x or conch of 80, and Laplace transforms of sinh of 80. That's all. And then we did the derivation. This is lecture 2. Quick review of lecture 2. We say Laplace transform of sinh of what? Sinh of 80. Tell me the formula is equal to what? Madam. Johari. A over s square minus what? A square. That's all. But you have to know how to derive, because I know in one of fine exam, they ask students to prove this. Right? So you have to remember the formula, but you have to know how to derive, because it's simple. Then I taught you, or we derived together, Laplace transforms of conch of 80. This is equal to what? S over s square minus a square. Is this it? So remember this, because the Laplace transform of hyperbolic function looks like a Laplace transforms of trigonometric function. They look like. They're just minor difference in sign. So be careful. And that's why that whenever I teach Laplace transform of hyperbolic function, the next lecture I have to teach about Laplace transform of trigonometric function. So you can see or you can note the difference. The difference is just a sign. Okay? In case you have missed what we discussed in lecture 1, lecture 2, visit our official YouTube channel called the Tanzania Online Institute of Technology. Visit the Department of Higher Engineering and Scientific Mathematics, or straightly go to the playlist of Laplace transform or playlist of calculus. You will access them. Right? So let us go to lecture 3. What are the names of lecture 3, students? So we say that in mathematics there are 60 trigonometric functions. Trigonometric what? Function. Which are what? Which are, the first one is what? Cos of x, let's say. The second one, Alex Saringe, sine of x. The third function, Gideon, tan of 40 of x. Then the fourth function is what? Sec of 40 x. The fifth function is what? Cosec of 40 of x. The sixth function is what? Cot of x. Tangent again. This is hyperbolic. Okay? In Laplace transform, we'll be discussing about Laplace transforms of the only 2 functions. Listen, sometimes they can give you Laplace transforms of tan, but it's not often, right? Often, frequently, we'll be asking questions with sine function and the cosine function sign, right? Just like in hyperbolic, okay? Okay? Remember that if you'll be asked the tan, it's simple, because we taught you that tan of x is equal to sine of x over cos of x. If you know Laplace transforms of cos, you just substitute. If you know Laplace transforms of sine, you just substitute. Class, are we together? Yes. So once you find a question, ask you to find Laplace transform of tan, don't say that, we didn't cover this in class. No. You just have to remember this formula that we taught you in secondary education. Are we together? Yes. So he said that often in Laplace transform, we have to learn the Laplace transform. of cosine and the sine function. Cosine and sine function. Sine trigonometrical function. Okay, class? Okay? Are we together? Yeah. So if that's the case, ladies and gentlemen, now let me teach you how to derive the mathematical formula of Laplace transforms of cos and the sine. So stop writing. In mathematics, you usually just use cos of x. Okay? In Laplace, we transform this cos of x or cos of theta, because you can use cos of x or cos of theta, right? In fundamental mathematics, we transform this one into cos of a t, where a is constant, t is variable, right? So this will be what in most cases our function f of t. Okay? Okay? Class, are we together? Yes. You will never find in Laplace cos of x or cos of theta. You may find cos of ax, but not cos of theta or cos of x. Right? Also, we are going to transform sine of x or sine of theta. We are going to transform it into what? Into sine of what? Sine of what? 80. This is equal to what? f of t. Class, are we together? Are we together? Is it clear? Those are still fundamental what? Scale. Write down. Okay, so now if that is clear, listen, stop writing. Now let me teach you the derivation of Laplace transform. You may write that subtitle, transform of what? Of sine of 80 and the cos of 80. Okay? Sine of 80 and cos of 40, 80. I think that now you understand. It's not a new phenomenon, because you have the experience of cos of theta and sine of theta from 2 basic mathematics. You are good in that time. Okay. So listen, stop writing. Ali. The first step. Recall the euros formula in complex number. I said stop writing, listen first and then you write complex number. Say euros formula. Say euros formula. We teach euros formula to our A-level students in Tanzania and to our ordinary diploma students, especially in T level 6. But maybe you forgot. Let me remind you. Euros formula states that it shows a relationship between trigonometrical function and the complex exponential function. Let me remind you. I believe in your mind, if you go and search, we have taught you this relationship. Cos of theta plus I sine of theta, this is equal to what? E power I theta. I believe you have something like this in your mind. In case you forgot, then I remind you, we need this one. Even in second year, because in second year, we have a module, first semester of second year, DAT, we are teaching our students the module that called the differential equation complex variable. So complex variable start with a complex number. Are we together, class? So this shows relationship that cosine of theta I just went back to what you know. I will convert this one into 80 at the angle. Okay? A cos of theta plus I sine of theta is equal to E power I theta. Say it. 1, 2, 3, go. If you don't remember that formula, you cannot derive the Laplace transforms of trigonometric function. So that's the key. Tell your neighbor that's the key. If this is the case, so this function, this formula show relationship between trig function, right, and exponential function and complex number. I is complex number, it's imaginary. I standing for under root of -1. You're being good in mathematics. That's why I love you. Do you remember that? I standing for under root of negative numbers. In secondary, in O-level school, we have been told that you cannot find the square root of negative number. Do you remember that? Once we are in OD or A level, we have been told that under root of negative number can be found. Right? By introducing what? I is equal to under root of negative 1. Are we together? So, this is the exponential function. Do you know exponential function? What the value of E? Just go to the scientific calculator, press shift, and then what? The button written what? Ln. Because above it, it's E. Then press the buttons of equal sign. E, it's 2.17 something. This isn't? Hope? 2.42. Then? Okay, that's the meaning. So E, it's a natural exponential function, okay? I, it's a complex number. Are we together? Are we together, class? Yes. Yeah. So let us transform this function to be the function according to the requirements of Laplace. In engineering system, most of dependent variables, they vary depending on time. That's why we have transformed the mathematical concept from theta into time, T. T stands for time. Okay? Are we together? Yeah. So for that case, let us transform together. What are we going to have? So we have to let that theta is equal to 80. Okay? Then if you substitute into this formula, we have what? Cos of 80, right? Plus what? I, sine of what? 80. This is equal to what? E power I 80. And this will be our function, which is called the FFT. It's a function vary according to the time. Class, are we together? Yes. Are we together? Yes. Are we together? Yes. So this one, we are going to call it equation 1. Okay? The next step, which is the second step, we have recorded the Euro formulas. The second step, we say that apply Laplace transform. L standing for Laplace transform. L standing for what? Let me write Laplace transform to help you, because you can say apply L. Apply what? L. And Laplace transform to what? Both sides of what? Equation 1. Okay? Class, are we together? So then we have L. We open the curly bracket. Then we have cosine of 80, right? Yes. Plus I sine of 80, right? Then close curly bracket. This is equal to what? Laplace of 40, Laplace of R. Laplace of 40, R. Laplace of I, A, T. This is equal to what? Laplace of 40 of FFT. Class, are we together? Yes. Are we together? Yes. Are we together? Yes. Well. So if this is the case, we say, okay, this will be our another equation. So what are we going to have? Let us introduce L. Open the bracket, right? We are going to have what? Aha. We are going to have Laplace transform of 40 cosine of 80. Say 80. 80. Plus 40. Laplace transform of 40. I sine of 40. 80. This is equal to what? Laplace transform of 40 e power I a t. Okay? This is equal to what? Laplace transforms of FFT. Are we together, class? Are we together? Yes. This will call it equation 2. Equation 2. Are we together? Yes. Okay. Write it. Okay. Stop writing. Listen and watch. Then after reaching this, after completing the second step, we are moving to the third step. The third step, we say that we have to consider in this equation 2 that we have, just let us leave, consider, let's say that consider lefty hand side. This is the third step. Consider lefty hand side. Okay, consider lefty hand side of 40 equation 2. Where's the left hand side? This one. We are going to leave this for a while because this is the one we have to derive this formula. Are we together? We refer equation 2 later on. Yeah, this is right. Oh, thank you. Thank you, home. Right handy side. Consider right hand side of equation what? Of equation 2. Okay? What the right hand side? Right hand side we have Laplace transform of e power I a t. Okay? Which is equal to what? Laplace transforms of 40 FFT. Are we together? I just consider this part and this part. Let us leave this. Okay? After that, we say that recall the general formula of Laplace transform. Recall general formula of Laplace transform. Right? What the general formula? Laplace transform of 40. Tell me. FFT, say it loudly, is equal to what? Integral from 0 to what? Infinity. Then e power negative st, FFT, dt. Ali, just to remind you. We say that in the steady state, we have to consider right hand side of equation 2. Where equation 2? This one. So we leave this for a while. We refer this equation later on. So we say that what do you have? Laplace transforms of e power I a t is equal to Laplace transforms of FFT, which is this one. The next step, recall the general formula of 40 Laplace transform, the one I did in I taught in lecture 1. Okay? And I mentioned it in quick review. Hello? Say the stop writing. So if this is the case, what is our function FFT? From this equation, our function FFT is equal to e power I a t. Okay? Just to compare this. L and the L, FFT is equal to this one. Are we together? Then we are going to substitute the value of FFT in this formula. Okay? So, Laplace transform of what? E power I a t is equal to what? Integral from 0 to infinity. Then e power negative st. Then we have times multiply by e power I a t dt. You should not be confused that why should you not apply Laplace transform of e power a t? This is constant. There's no imaginary number here. For this one, we cannot apply it because there's imaginary number. This is the complex number. Are we together? This is not like this formula. Okay? Are we together? This is the constant exponential function. This is exponential and the complex function. Are we together? Because of I. I is the square root of -1. Because I know most of Tanzanians say, don't complicate life. Just substitute 1 over s minus a. No. Are we together with these 20 students? Then we can write this one as integral from 0 to infinity e power negative st multiplied by e multiply, we can use a dot, e power I a t. Then what? dot dt. Are we together? After that, we say that the first state, this is the product of two exponential functions, right? Recall the rule of multiplication of exponential function. Recall, say that rule of exponential function. In exponential function, as the first topic in basic mathematics form 2, we taught you that if you have, let's say, 2 power x multiply by 2 power y, because the base is the same, add the exponent, right? So what did we teach you? 2 power x plus what? Y. Similarly, in exponential function, if you have e, let's say, power a, multiply by e power b. This is a multiplication of exponential function of the same base. The base is called e, right? So because the base is the same, add the exponent. So it will be what? E power a plus what? B. Are we together? Yes. Are we together? Yes. Well, so if that's the case, we are going to apply. So this is equation, you're welcome. This is equation 3. So we are going to apply that concept to solve this. Okay? Because this is the product of two exponential functions. This is the exponential function, this is the exponential and complex function. Okay? So for that case, we say that we have e power negative st plus, or we say that multiply by e power I at. Same base, add exponent. So it will be e power negative st plus I then at. Are we together? Are we together? This will be our equation what? 4. Then once we do the multiplication of exponential function, now we'll be writing equation 3, but we are going to replace this one with this function. Are we together? Yes. So if that's the case, you say that Laplace transforms of e power I at. This is equal to what? Is equal to integral from 0 to infinity. Of what? E power what? Tell me e power what? You can open bracket e power negative st plus what? I a t. Then close bracket of exponent, right? Then you have what? dt. This will be equation what? 5. Did you understand up to that point? Hello, Johari, are you there? Don't think about integration. We did not do anything about integration there. This is just a simple simplification. Is it clear? Right. Okay. So if this is the case, we have now equation 5. Okay? We have equation what? Equation 5. So it's equation 5. What do we say? Let me copy equation 5 first at this point. Laplace transform of e power what? Open bracket. Power I at. Say it. Laplace transform of 40. I don't hear the voice of other students. Is equal to what? ST, IAT. If you pronounce these integrals, you reinforce in your brain. If you don't pronounce, then you write and you are waiting to cram. So after this, now we are going to the fifth step. Say fifth step. Stop writing, stop writing, stop writing, listen. So the fifth step, we say this is equation what? 5, our equation 5, okay? Still the same equation, we just copied it, right? Then the fifth step now, we say integrate equation 5. So we are diving, or we are moving to the integration. Hello brother, stop writing. To the what? Most challenging concept for the adult students. So this is the very simple integration. Before we dive into integration, I think, let me simplify one thing. Before we dive into integration, let me simplify. Or should I? Yes. Okay. Yeah, I will simplify somewhere. Yes, I will simplify somewhere. So how do we integrate? Separating. The way we integrate, this is the exponential integral of exponential function. The first step to integrate, we have to let this part. Let u is equal to negative st. But before we let, I think that we have to do something. Wait, sorry. Let us do some simple simplification before integration to simplify the concept. What should we do? Listen. We say Laplace transform of e power iat is equal to integral from 0 to infinity. Then e power, open bracket. What the common variable here, or the common letter? T, right? So we can take t out. So you have negative s plus what? I, a, close the bracket, t, dt. Is it clear? Is it clear? Then we want to take this negative out. Okay? So when you want to take that negative out, it will be integral from 0 to infinity of what? E power negative. Open bracket. If you take negative out, this will be positive s. So we'll have positive what? S. Right? Then here we are going to have, it will be minus. So minus what? I, a. Then we have what? T. Then what? The t. Are we together? Then for that case, we can have our equation 6. You should not worry about the number of equation. Just understand. The integral from 0 to infinity. Then e power negative what? Mention. Power negative negative what? Open bracket what? S minus what? IA what? T. Then what? The t. This is equation what? 6. So now we can integrate it easily. So we move the fifth step. So the fifth step what? Integrate. Integrate what? Integrate equation what? Equation 6. How do you integrate? Simple. We have to let. And before we let me remind you one thing that we taught you in fundamental of calculus. Okay? Are you ready? Listen. We taught you that if you want to integrate e power x dx, the answer is e power x. Okay? If you integrate e power x dx, the answer is e power x. Are we together? For that case, if you're integrating e power t, the t for instance, the answer is e power t. Are we together, class? Are we together? Yes. But this is, we call t indefinite integral. It does not have what? Limits. Okay? If you introduce a limit, Then let's say limits is from a to b, then you integrate e power x dx. This is equal to what? It will be equal to what? E power x close bracket from a to b. Are we together? Yes. Then for that case, substitute the limits. It will be what? E power b minus e power a. Are we together? We are just reminding you, because this is the technique that you are going to use to integrate. Do you remember that? Do you remember that? Okay, I just reminded you. Is it clear? Is it clear? This is still simple. This is a little bit complicated because you have e power negative something and whatever. That's why I use the simple function to understand the concept. Because now the next step, I will tell you that x is equivalent to this. Right? A is equal to 0. B is equal to infinity. That's the point where I'm heading to. Are we together? Yes. Okay, right. Okay, so after reminding about the fundamentals, stop writing, listen and watch. After reminding about fundamental skills of integrating function, now let us go back to integrate our equation 6. Okay? 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 So how do we integrate? We have to make sure that we transform this exponent to be like x. How? Simple. Let u is equal to negative, open bracket, s minus ai or ia. You may start with a or you may start with I. Okay? So instead of negative s minus ia, later on we'll just write u. And once we have u, it's just like x. Okay? Then after that, the next step, because I'm going to change the variable, say change variables. We are going to change the variable from t to u. Right? So instead of having this part of t, we are going to have u. But we still have dt. dt, it means derivative of time. We have to differentiate this function to find the u dt. Ah, I forgot t here. Right? Then next t, we are going to differentiate. Find the u dt of what? Of this one. D dt of what? Negative. Negative, open bracket, sai. Then we have what? T. Okay? So listen. To differentiate that, it's simple. Just remember. We taught you how to differentiate a function which is 2y is equal to 2x. 2a, y is equal to what? How do you differentiate? If you find the y dx, this is equal to 2. Do you remember that? Simple. Remember the formula which you call d dx of x power n. The answer it is n x power n minus 1. Do you remember that? So for this case, our n is 1. Our n is what? So what you have done here, this is the formula, right? N is 1. So we have 2 as a constant. Let us differentiate x. So we have 1, right? Then what? X power 1 minus 1. Because this n minus 1. N is 1. Okay. 1 minus 1. X power 0. 1 times 1. 1 times 2. That's why the answer it is 2. Are we together? Are we together? So for this case, 2 is it looks like this constant. This is the constant. All of these are the constant. The variable is just it. Are we together? Na maanisha hivi, y sawa na 2x. Nimerudia au nimekukumbusha, yani function rahisi ya enzi hizo ukiwa kijana. Sawa? Tuna differentiate vipi? Formula kanuni yake ni hii. Kwa sababu hapa si x, manake unaweza kuja ukuta ndio hizo tukasema 2x square. Kwa 2 ikuwe na shuka, unazidisha, unatoa kwa juu. hizi zako hizo. Sasa baada ya kukumbusha hivyo, kwenye function hii hapa n yetu ni 1. Kama tuna 2 tunaitoa nje ya mabano. Baada ya hapo n si 1, formula huko inatuambiaje? N inashuka kwanza, tunaandika x, tunachukua n toa 1. Kwa hiyo hapa tumeweka 2, tumeweka mabano sababu hiyo ni constant. Baada hapo tumeshusha 1 hapa ikaja hapa. Alafu x kama hapa kwenye formula. Alafu 1 toa 1 ambaye ni n toa 1. Hapa n ni 1. Baada hapo 1 toa 1 ni nini? 0. X power 0 ni nini? Aya, 1 mara 1 ni nini? 1 mara 2 ni nini? Ni 2. Kwa hiyo hii 2 hapa inafanana na hasi, fungua mabano, s toa i. Ndio maana nimekukumbusha hii ya enzizo ukiwa kijana, ili nikulete hii ya enzizo ukiwa mzee. Mmenielewa? Haya, then for that case tunasema hivi, du sasa dt. We say du dt for this function, this one. What are we going to have? This is value of n, it's 1. Okay? It is t power t 1. If that the case, then we have what? In bracket, we are going to have negative. This is constant. Negative what? S minus what? AI, close bracket. Okay? Then our x is what? T. What the value of n? 1. Multiplied by what? T. Power what? N. N is what? 1. Minus what? 1. That is. Are we together? 1 minus 1. T power 0. As 1 times 1. 1 times negative s minus ai. Yes. So if you differentiate that function, the answer is negative s, negative open bracket, s minus ai. Are we together, my dear student? After that, the sum of differentiate this function is to find the value of the t. This one. We have to change from t to u. And you have to listen because we have a lot of this mathematics in Laplace. We'll be discussing about integration by parts, whatever. So this is just I'm introducing to you, but you have to remember, and I repeat it several times in your mind until you master. Okay? Okay? So if that's the case, let us write this equation simply. Du dt is equal to negative s minus ai. Are we together? After that, let us make dt the subject. How do we make dt the subject? Simple. This one is always over 1. Then cross manyapu or cross what? Multiplication. So once you cross multiplication, we get it. 1 times du is equal to what? Du. And then you have negative s minus what? ai. D what? dt. Make dt the subject. So we are going to divide by negative open bracket s minus ai. Then for this case is negative s minus ai. Okay? For that case, we say that dt is equal to, you can take this negative up. There's no problem. You may have negative in numerator or in denominator in case of fraction. So dt is equal to negative du over what? Over s minus ai. For that case, this is what will be our equation what? Equation what, class? Equation 6 or 7? Equation 7. Did you understand a little bit? Did you understand a little bit? Right. We review through the video several times. Okay. So this is all about step number 5, or the fifth step. Now, let us substitute equation 7 and the equation what? Substitute, let's say that, let's say this is equation 7. This is equation 7 and this is equation 8. Let us substitute equation 7 and equation 8 into equation 6. That's the next step. Listen, listen, listen. I say stop writing. Watch and look. This is equation 6, right? We have let u is equal to negative open bracket s minus ait. Hello? So, in the next step, we are going to replace negative open bracket s minus iat, close bracket t, with u. Okay? And then we are going to replace dt, this dt, with negative du over open bracket or over s minus ai. Are we together? Well. So if that's the case, what do you say? Well, that's wonderful. So this is the sixth step. Substitute equation 7 and the equation 8 into equation what? Equation what, class? Equation 6. Okay? Okay. So let us remind ourselves equation 6. Equation 6 is said that Laplace transform of e power ait, this is equal to what? Integral from 0 to infinity. Okay? From 0 to infinity, and then e power negative s minus ai t, right? Dot. This is equation 6. Okay? This is was our equation 6. Now, we say that Laplace transform of e power a it is equal to what? Is equal to integral from 0 to infinity of what? E power what? Power u. Why? U is equal to negative open bracket s minus ai close bracket t. Right? Then we have what? dt. What's the value of dt? Yes, you can just have this one for the overview. But don't do this in exam. Okay? So then we say what? dt is what? Negative. Say it. Du over s minus what? ai. So you see that all the variables are u. We don't have any t anymore. Are we together? Let us simplify. How do you simplify? We say that this is integral from 0 to infinity of 40 of negative du over what? Sorry. This is e negative e power u over s minus ai. Okay? Then dot. Are we together? So we are going to simplify our integral. E power a or I at. This is equal to what? We take negative out. Okay? Then this is constant because we don't have any u. S is constant, a is constant, I is constant. You are allowed to take any constant outside of the integral sign. So you are going to have negative what? 1 over s minus ai. Okay? Okay, class? Integral from 0 to what? To infinity of 40 a e power u dot. Are we together, class? Yes. Recall, I taught you what the integral of e power x dx from a to b. What is it? It's e power x from a to b. Okay, Johari? And then this we said what it will be e power b minus e power t. Are you together? So we are going to apply this technique here. So for that case, you say Laplace transforms of e power I at, this is equal to what? Negative, open bracket, 1 over s minus ai. Okay? Then we are integrating this one. So you have e power u du. If you integrate, what do you get? If you integrate e power u du, what do we get? Class, if you integrate e power x, I told you, if you integrate e power x dx, we get e power x. If you integrate e power something, you get e power something. So if you're integrating e power u, what do you get? That's the answer. So then we use to square brackets. The answer of our integral will be e power t, a, from what? 0 to what? Are we together? Then after that, we have to restore this value of u, because these are the limits of t. This is in limit is a t, so limit is a u. Kwa hiyo natakia tutoe u, yani tuiondoe u turudishe hiki kitu. Ndio hesabu inavyoenda, inaenda mbele, narudi nyuma, inaenda mbele. That's the goodness of mathematics. So, what are we going to have? Negative, say it. Don't get surprised. Negative open bracket, 1 over what? S minus what? AI, okay? Then open square bracket, e power what? Negative, open bracket, s minus ai, t, close bracket. From 0 to what? That's all. Did you understand? Did you understand at that point? Right. Okay. So after that, let us continue. So let us recall what we have here. Let me write. Stop writing. Laplace transforms of e power a I t is equal to what? Is equal to negative 1 over s minus a, then open bracket, e power negative open bracket, s minus ai, then have what? T, close square bracket from 0 to infinity. So let us finish our problem right now. Our process of integration. Say stop writing. Are we together there? Yeah. So, what do we say that? We say that's fine. We are going to substitute the limits. Hello, Ali. We're going to substitute the limits. If you substitute the limit, this is equal to what? Open bracket, sorry, negative 1. You can say also negative 1. You can set negative there. S minus a. Then we say what? E, substitute the upper limit. E power what? E power what class? Power negative. Negative what? S minus what? AI. The upper limit is what? Times infinity. Right? Upper limit. Okay? Okay? Minus what? E power negative, open bracket, s minus ai, multiplied by what? By 0, close bracket. Where is t? T we replace, it means substitute the value of t, which is infinity and 0. We replace t, yani kwenye t tumeondoa tumeweka infinity hapa, na hapa t hapa tumeondoa tumeweka 0. Si ndio hii hapa tuliofundishana jamani, kama kuna a mpaka b, ukishaweka hizo limiti zako, manake b hapa kwenye x tutaweka b, ndio hii. Toa hapa tumeweka a, ikaja e power a. Ndio msingi huko hivi. Are we together? Is it clear? Class, is it clear? Next, what do you say? That's fine. So this is equal to what? Negative 1 over s minus what? Oh, I forgot I. It is ai. And then even yourself you forgot, because you are no longer in this derivation. So s minus ai. Okay? Okay, class. Then next we say that we have E. Infinity S minus AI. Remember, this is the constant. Hii ni namba fulani. Namba fulani mara namba kubwa. Infinity number kubwa. The large number multiplied by a certain number. What do you get? For instance, 1 trillion multiplied by 10,000. What do you get? Trillion. Right? So infinity times any constant number or any number, it is infinity. So negative S, or let's say S minus AI times infinity, the answer it is negative infinity. Are we together? Then minus what? Minus. Then S minus AI, which is the constant, times 0. Any number times 0. 0. Minus what? E power 0. Are we together? So this is still Laplace transform of 40 e power AIT, which is equal to what? Open bracket, negative 1, S minus AI, then e power negative infinity minus e power 0. E power 0 is what? 1. Are we together? Then now it's come to the case. What the value of e power negative infinity? Take your calculator. Take your scientific calculator. I believe that you agree that infinity is the largest number, very large number, isn't it? Take your scientific calculator, press shift, then press the button written ln. Then after that, press the button written power. Ready? So now you have E power. In a scientific calculator, we expect you to see this on the display. E power. Right? Right? Then open bracket. Then write negative 99. Or let's say negative 9 exponent 99. So 9 exponent 99 is a very large number, isn't it? A number which has 99 zeros. It's a very large number, isn't it? Is it a trillion or what? It doesn't have the name, So what do you expect to see in your calculator? You have to open the bracket, write negative 9. Then I think sometimes exponent is this one, 99. Do you have something like that? What do you have? Pardon? What is the syntax error? Where did you get syntax error? Can I have one calculator? What is syntax error? I say just press shift power, open bracket, negative 9 exponent 99. Syntax error. Okay, shift E power, open bracket, negative. So negative infinite 9. 9, okay, so let's say that 9 exponent exponent 50. Syntax error. Shift E power negative 9 exponent 10. Shift E power shift E or alpha alpha E power, open bracket, negative 9 exponent 99. It's alpha, not shift, sorry. It's alpha. Press alpha. You get it? Aha, you get 0. So E power negative infinity, for that reason, it means that E power negative infinity is equal to 0. E power negative any large number, it's 0. Is it clear? Is it clear? So remember this for the rest of your life in Laplace transform and even advanced calculus. So for that case, we say that Laplace transform of e power a I t, this is equal to what? Open bracket, -1 over s minus ai, open bracket, e power negative infinity. Oh yeah. E power negative infinity, say it loudly. 0. 0 minus what? 1. 0 minus 1, what do you get? -1 times -1. So our response is 1 over s minus ai. Are we together? Is it clear? Write down. So let us continue. We ended this step number what? Check in your exercise book. Step number what? The sixth step. So let us recall our final equation. Laplace of e power a I t. This is equal to what? 1 over s minus ai. So this is what we have been looking for. A simple one. Are we together? So then this will be equation what? 9, Yes, equation 9. So equation 9, we have to perform the second from the last step. We just have 8 steps in this derivation. So the 7th step is this one. We say that rationalize the lefty, the right hand side of equation 9. Why should we rationalize? Listen, there's the reason. Remember that in our equation 2, equation 1, if you do remember, we had this something like this one. Laplace transform of cos of at plus what? Plus I. Sin, Laplace transform or Laplace transforms of I. Sine of at. If you do remember. Do you remember it? Then is equal to what? Laplace of e power I at. Do you remember this equation? So we have to rationalize because we have to simplify this integral to be like this, to be in this form. So we can compare left hand side and right hand side. Yani hii tunaita ni real part. Na hii tunaita ni imaginary part. Ikiwa hivi bado iko very complicated. Huwezi kucompare ukasema kwamba real part ya huku ni sawa sana imaginary part. Ndio maana nataka tu rationalize. Tukisha rationalize hii I itapanda juu. Afu tutaiweka vizuri tutaifananisha na hii. That's the aim. Okay? That's the point where we are heading to. So stop writing, listen and watch. Okay, so if this is the case, what do you say? We have 1. Let me remind you the concepts of rationalization. Say rationalizations of denominator. Let me remind you, we taught you in exponent, the first topic, physics, basic mathematics form 2. Let me remind you. We used to have this one, that let's say we have 2 over x minus 2. If you rationalize the denominator, then we have to multiply to both numerator and denominator by x plus 2 over x plus 2. Do you remember that? If it's minus. If it's plus, you have to multiply by x minus 2 over x minus 2. You do see that you are competent in mathematics, eh? You have a good foundation of mathematics. Do you remember about that? So similarly for this case, so we have 1 over s minus ai. How do you rationalize the denominator? Rationalize the denominator. Say denominator. Denominator in right hand side of equation 9. How do we rationalize? We open bracket, we close bracket. We have to multiply with what? S plus ai over what? S plus ai I. Are we together? Are we together? Are we together? Yes. For that case, you say what? S plus AI times 1. S plus AI plus 1. So S times 1, it's S. AI times 1, it's AI. Do you agree? Do you agree? Do you agree? Yes. Then S times S. S is square. Very good. Then S times AI. So plus ASI. Okay? Then negative AI times S. Plus, is this negative, ASI. Okay? Then negative AI times AI. This will be AI square. Are we together? Are we together or we are not together? Negative, Thank you. That's why you stuck. Very good. Nice, okay. Are you there or you're not there? But you're unhappy. Not because that I don't teach you well, but the mathematics is a little bit tough. Are we together? Can you simplify this? Yes. ASI minus ASI. What do you get? 0. So, for that case, remember that we are still dealing with Laplace of E power AIT is equal to what? S plus AI divided by what? Minus AI. Then this one is what? Square. Are we together? So Ali. S plus AI. Just concentrate. I will give you the time to attempt that emergence. So this will be S square minus A square, then I square. Do you agree? Yes. Yes. So in complex number, remember that, but I is equal to under root of negative 1. Right? Yes. So if we square this to both sides, if you have I, then we square both sides. This is under root negative 1 squared. Okay? So for that case, I square is equal to what? I square is equal to what? Negative 1. So instead of I square, we write negative 1. Simple now, So for that case, you say Laplace of E power AIT. Say it is equal to what? S plus. You are not saying now loudly, especially gentlemen. Over what? S square, minus A square times what? Negative 1. Are we together? Is it clear? Right. Okay, so for that case now, this is the point where we are, right? Separating, negative 1 times negative. Positive A square, right? So therefore, Laplace transform of E power AIT is equal to what? Is equal to S plus AI over what? Over S square minus what? Plus what? A square. Okay? Then next, we have to do very simple simplification. Very simple. What kind of the simple simplification? This fraction, we may write it as S over S square plus A square. Do you agree? Then plus I, let's say IA over S square plus A square. We did not change anything there. You had it? Did you understand? Yes, you can find LCM. It's this one. Take this times this, divide by this one, you get s, 1 times s. Okay? So we split the fraction. Are we together? Then, next, we say Laplace transform of e power ait is equal to what? Is equal to s over s square plus a square plus I, open bracket, a over s square plus a square. This is equation 10. Okay? Then we are going to the last step. The last step is what? 8th step. So the 8th step, we say that, recall what? Equation 1. Equation? Remind me equation 1. Laplace transform of 40 cos of 80. Plus what? Laplace transform of 40 I sine of 40 80 is equal to what? Laplace transforms of 40 e power a I t. So this is what you have been looking for. This is the right hand side we considered. Okay? I, it is constant. We can take out of Laplace. So then this equation you can rewrite as Laplace transform cosine of 80 plus I Laplace transform sine of 80. This is equal to Laplace transforms of e power a I t. Are you together? Are you together? So recall equation 1 and D. So this is step and D. Compare. Say compare. Compare with equation 10. So if you compare equation 10, we say Laplace transform of cosine of 80 plus I Laplace transform of 40 of sine of 40 80. Okay? This is equal to what? Is equal to s over s square plus a square. Okay? Plus what? I. Then a over s square plus what? A square. So this is the real part, you will compare with this. This is the imaginary part, you will compare with this. Then mathematics is beautiful. For simply this one, we are going to compare with this. Let me use these arrows to remind you. And this one, we are going to compare with this. You have I, you have I. No I, no I. What? No I, no I. Hello, that is mathematics. That is Laplace transform. For that case, you say Laplace transform of cosine of 80 is equal to what? S over s square plus a square. So this is important formula. You have to remember it for the rest of your life. Also, we say that Laplace transform of what? Sine of 80 is equal to what, Ali? Is equal to a over s square plus a square. This is important formula. During your traditional classes, your teacher just came and write this and this. Then move to the next concept. But in exam, you may be given, you may be asked to show that Laplace of cos of 80 is equal to this. The challenge for this derivation, you cannot derive for cosine itself, or you cannot derive for sine itself. You may be asked this to show this one. You have to follow the same process. Once you reach to this stage, you skip this one and this one. And then you consider this function and this function. Are you together? You may be asked that to show or prove that Laplace transform of sine of 80 is equal to a over s square plus a square. You have to follow all the procedures And then in this step, you will skip Laplace transforms of cosine of 80 and s over s squared plus a squared. Are we together? Are we together? Yes. Are we together? Yes. Yeah, so that's the point that you have to note. What I'm teaching you, I have seen in test 1, yes, mostly test 1 in the free and supplementary exam of DIT examination, or the Dar es Salaam Institute of Technology examination, in calculus and engineering mathematics. So I didn't teach you because I want you to master mathematics. No, I just taught you because it happened, this question has been asked. Are we together? The last point that you have to note, differentiate, you have to remember the difference between Laplace transforms of Cauchy of 80 and the cos of 80. The difference here is the sign. For the Cauchy of 80, we have minus. So if you claim these formulas, you will confuse in the exam. In case, you have also to note the difference between Laplace transforms of sinh of 80 and Laplace transforms of sine of 80. The difference is just the sign here. For the Laplace transforms of sinh of 80, here we have minus. But the variables and the constants are the same. So you know that one of the challenging thing in mathematics is actual contradiction or the battle between negative and positive. Because sometimes you say, this one, this is minus. Then you solve a question, say, no, this is plus. And they say, no, this is minus. And they say, this is plus. Right? So that's why I would like you to ask you to note the difference in advance. Because in the exam, you might miss a lot of marks because you are contradicting yourself, whether it is positive or negative. You say positive, after time, negative. Positive, negative. And finally, you write the wrong answer. That's the challenge. Just like if the answer is A or B. You just write A and they say, no, B. Then A. Then B. It's a very challenging. Students, have you understood? Yes. Have you understood this derivation? Yeah, let me congratulate you. You have a question? It depends. If the final exam, the marks you might be given even 5 marks. It's a final exam. If it's a test 4, 5, it depends. The issue is not the marks. In case of the test, you will have few questions. In test 1, they usually ask you 4 questions. So whether they have few marks or they have a lot of marks, you have to solve it because they are few, you don't have multiple options. Are we together? In final exam, sometimes if they ask you in this one, then they can give you 7 marks. Okay? Yeah. You might think that it's difficult derivation because it's the beginning. But when you be reviewing and reviewing, you find it simple. And also in case of exam, you are not supposed to write everything. For myself, I wrote everything because I'm teaching. Some of the points you'll skip. For instance, this one. What that is e power x, integral of e power x. I was just reminding you. It's not necessary to write. So don't think that in exam you have to write all of the steps. No. Some of them you can skip because you are rushing with time. But when you are learning, write all the steps so you could know that, for instance, this one, okay? We are rationalizing the denominator. Finally, it will be something s squared plus a squared. So you can skip. Are we together, class? So before I give you questions that you have to solve by using this and this, I would like to congratulate you because you have understood the first, the fourth, I think the fifth derivation in Laplace. Okay? So let me congratulate you. You did the work. So you deserve to be congratulated. 1, 2, 3. Hongera for coming. Imara for learning. Wow for understanding. Write down. Okay, so after deriving the Laplace transforms of cos of 80 and Laplace transforms of sine of 80, the next step that which we are supposed to do is we are supposed to solve some problems of Laplace transform. Okay? So how we are supposed to solve? Well, that is good. This is the way that we are supposed to solve, or these are the questions. In lecture 3 or lecture 2, we ended example 4. So this is example 5. Find A or find Laplace transform of the following functions. Function number A, cosine of 5t. B, cosine of negative 7x. Then C, cosine of negative 5/9t. Roman A or A, B, C, D. Then we have to find sine of sine of 8t. Roman E, A, B, C, D, E. You have to find sine of negative 0.78t. Roman F, let us find sine of negative 3 over 4x. So these are the sample questions. Those are the sample questions. Okay, so right now, ladies and gentlemen, separating, let us solve some few examples. So let us start with Roman A. We are supposed to find Laplace transforms of cosine of 5t. Say Laplace transforms of cosine of sin t. Say Laplace transform of cosine of 5t. So Laplace transform, we have been asked to find Laplace transform of cosine of 5t. This is what we have been asked to find. Okay? Well, so if that's the case, you have to say that recall what? Ali. Laplace transform of what? Cosine of a t. This is equal to what? S over what? Minus what? Minus a square. Plus. Thank you very much. For this case, what the value of a? 5. Then we say that what? Laplace transforms of cosine of 5t. This is equal to what? S over s square plus 5 square. This will make what? S over s square plus 25. So the final response for Roman A, Ali, I didn't say right. Say listen. Is equal to what? S, you have to simplify, especially the square, 25. So this the final response. Are we together? Ali, it's simple. We have been asked to find Laplace of cos of 5t. Recall the general formula. Laplace transform of cos of 8t is this one. We derived it. So A, if you compare, it's 5. So in position of A, just put 5 square till you take 5. That's all. Okay? So this one, I will leave it for you to try. Cosine of negative 7x. So the variable, remember that having x or having t does not change the right hand side. Because the right hand side we just have AC and A. Yaman, function kuwa na x au kuwa na t haibadilishi chochote kwenye jibu, inabadilisha tu kwenye formula. Ngoja basi tufanye hiyo. B, find Laplace transform, I said separating, of cosine of negative 7x. This is equal to what? So this is equal to something. So we say recall Laplace transforms of what? Cosine of ax. This is the difference. Then is equal to what? S over what? Plus a square. Okay? Well, so if that's the case, what do you say? That's good. We say, what is a? Negative 7. So Laplace transform of 40, negative 7x, cosine of negative 7x is equal to what? S over s square plus negative 7 square. This is equal to what? S over s square plus 49. So this is the final response. Hello? Oh yeah. So let me solve the other one. So for the decimal, the same story. This is a. Right? Yes. This is a, negative 5 over 9. This is a. This is a. Let me solve this one, and then I'll leave this one for you at the quiz, and this one, and this one. Okay? So for Roman F, we are supposed to find Laplace transforms of 40, sine of 40, negative 3 over 4x. This is equal to what? Okay? So recall the formula for Laplace transforms of sine, hope. So recall Laplace transform of sine of 80. This is equal to what? Sine of 80, Laplace transform of sine of 80. Line. A over a square plus a square. Right? And what is a? 830? Negative 3 over 4. Okay? For that case, you say Laplace transform of sine of negative 3 over 4x. This is equal to what? This is equal to negative 3 over 4 over s square plus negative 3 over 4 square. Then what do you say? This is negative 3 over 4, then s square. Negative 3 times negative 3. 9. Positive 9. 4 times 4. 16. Then you find the LCM. It will be 16. Here it will be 16 s square. Then here it will be 9. So 16 will go up. Right? So this one will be what? Negative 3 over 4 times what? 16. Over what? 16 s square plus what? 9. If you simplify this one, it is what? Right? So the response is what? Laplace transforms of what? Sine of negative 3 over 4x is equal to what? Negative 12 over what? 16 s square plus 9. Remember that, as I say, you will never find questions like this in exam the way they are. But this is the part of the big question. You might be given a function like this one. f of x, find Laplace, let's say, of x cubic plus what? Plus e, or let's say plus what? Plus sine of 60t. Then minus what? Minus inch of what? Negative 3 over 4, let's say t. So do you see that? This is the part of the entire function. Okay? So sometimes out of the function you have to split them and treat them separately. Because the formula of finding Laplace for this one is different from the one of from the formula that we use to find Laplace of sine of 60, and also it's different from the formula that we are using to find the sinh of negative 3 over t over 4t. Are we together? So this scale will prepare us to solve those questions. So questions like this one. Did you understand? Yeah. So you have to try Roman C, Roman D, and D, Roman E. After that, then that will be the end of lecture 3. In lecture 4, I will teach about Laplace transforms of the double angle, and possibly I will teach about the factor formula. It's very important. So, my dear students, I would like to say that this is the end of lecture 3. Thank you very much for joining us. We'd like to welcome in the next lecture, that will be lecture 4, where we'll teach about Laplace transforms of the double angle. We ask you to practice, and we ask you to review the derivations of Laplace transforms of trigonometric function. And because you've done a work, you understood the derivation, you did some simple examples, and you have a quiz. That's the quiz, not a homework. You have to read in the class. So I think it's better to appreciate you for the work that you've done today. So get prepared. No one who is appreciating you in the street, even in your family. They always criticize you. You didn't do, you didn't do. You did bad. 1, 2, 3. Hongereni. Imareni kwenye hesabu. Wow. Thank you very much. May God bless you. See you in the next class.